What is up, YouTube? And welcome to episode 23 of the Chaos Daily. We're going to get straight into it today. I was on a roll. I was in the zone. I was just flying through it. So, Simon's messaged me. He's like, come on, man. Where are the files? Where are the parts? Come on, I want to try test printing this stuff. I'm like, we're nearly there, man. I've got some of them ready. Like, just hang on. So, I spent most of the day getting a whole bunch of parts ready to export as STLs to send to him so he can start test printing. And yeah, boy, did I get some done. Let's just jump straight into the time lapse, and then I'll see you on the other end to talk about what I did, how I did it, and why I did it. And by the way, I solved the servo mounting problem. Don't know why I didn't mention that first. All right, let's get on with the time lapse. So yeah, there you go. We've got basically everything done from the nose to just before the tail starts. Tail section is next. I want to work out how I'm going to get the tail section and the aft midsection to connect together nicely. We'll be using these kind of 6mm by 1.5mm magnets. 4 of them on each mating face. There's going to be 2 mating faces. That's going to be between the canard and the fore midsection, and between the fore midsection and the aft midsection. So normally you would probably just glue the canard section to the fore midsection if you're not going to run elevators on the front, and you just glue it and the whole front of the plane becomes one solid piece. But if you want to run elevators at the front, you want to be able to access the servo mounted between the fore midsection and the canard section. So I've designed it so that you can use magnets there. So everything slots together on the 2 carbon fiber tube rails. There's 2 carbon fiber tubes that run as rails through all the parts from the tail to the canard section, and you can just pull it apart at any point along the line and access the different things. So normally you'll just be pulling it apart in the battery section using the electronics tray so that you can access your battery and your receiver and stuff like that. And it all gets held together with these magnets. So yeah, these are great. These little magnets, they're super strong for how small they are and light they are. And there'll be a set of 4 on each face, so 8 in total. Anyways, so yeah, let's jump into Inventor and I'll show you what I've done, and I'll show you the parts that are ready for me to send to Simon so he can start test printing them with FDM, and I get to sit and wait until my printer arrives in 15 days. Yeah, I'm counting, all right. Oh boy, I'm counting. So yeah, let's jump into Inventor. So here we are. I've created a quick little build plate. This is my build volume on the Phenom. So I can pretty much print almost all of the aircraft, all of the fuselage section minus the tail in a single print. How cool is that? If you're wondering where the nose is, it's hiding on the inside here. This is with the clear blue from Tech. Oh, this resin is going to be so gorgeous. Being able to see all the internal stuff. But yeah, so we've got aft midsection, the fore midsection, and they are connected with electronics tray. And this electronics tray holds your servos. And the way I've done that is they sit on that little servo tray on that platform here. It's next to each other. And then you zip tie them with this sort of fin in between them. And there's a hole there for the zip tie to run through. So you just zip tie them to this whole electronics tray. And then you can, glue it to the aft section so it stays fixed with the aft section. And it still slots into the fore section. So if we have a look over here, we've got the aft section, the midsection, the canard section, and the nose cone. And over here, I've got the nose cone hiding on the inside there. Now that'll print for me on my resin printer all in one go. And there's enough space on the inside to print the nose there, and you can still get it out. And nose section and the canard section are aligned with this sort of alignment pin that slots in through the back of the canard section, and there's a little lip on it so it catches on the rim here on the inside, like so. And it will stick out a little bit. And then on the nose cone section, it will stick into its corresponding hexagonal hole. So that'll all slot that together. Now you got some options on how you want to affix this. I would recommend probably some like double-sided tape, so that if you have a crash or something and you damage the nose, you just need to print the nose and just pop it off and reprint it and put a new one on. So I'm thinking ahead for those sort of things, for like maintenance and repair and that kind of stuff. So that makes that life easier there. On the similar note as this sort of plug, there is this one here. Now this one's weird because it goes from a hexagon to a square, and that's because of the battery tray. But this section, this piece here, this I'm going to design so that I can also mount a servo on this for your elevator. So if you choose to go the elevator route using the front canards as elevators, then there'll be a version of this connection piece that you can mount a servo to. And then you glue this section with a square peg in the square hole, and then the hexagonal hole sticks out. And there's still enough room here for these magnets. So these are the holes to seat the magnets. So this face meets up with this face, and you can see those corresponding holes for you to epoxy the magnets in. And then there's your hexagonal ring, and this hexagonal ring allows you access to the inside where you can slot that square peg, that hexagonal peg. It's a bit of a puzzle. I'll make an animation of this all going together so you can see how it all fits together. But I was lying in bed last night trying to figure out how to get these servos, these damn servos to mount, and then it hit me when I was thinking of unrelated. I was like, okay, how am I going to connect all the parts? Am I going to use like little alignment pins or little alignment pegs? And I'm like, yeah. And then I thought, well, what about like making them bigger so it's like a ring that has a hexagonal shape or a square shape or whatever. And then it's bigger. I can put a servo in it and put a servo mount in it so that you can mount your servo to it, and then you mount that to the plane however you want, and then there it's done. Like, it's not a big hassle. So that worked out really well for this one. So if I hide, say, the battery compartment tray, which is your 4 midsection, then you can see it sticks out just a little bit on this side, and it slots mostly into here. So on here you can see those same 4 points to put your magnets. So this will connect back up to this one, and this one also has the holes for the magnets. So everything goes together very well. You can see how this one slots in here with the hexagonal sticking out, and it goes together like that. So all these parts are combined. They're ready to export as STLs. They are good to go. I'm really happy with the way they turned out. I'm thinking I might find a couple of ways to reinforce this tray. I know, I'm still going to work that out, maybe put in some more gussets here, but the problem is the way that this has to print, both for me, well, for me it's not so much an issue with the resin printing because I can do stuff upside down pretty much. But for FDM printers, it'll be printed up this way in this orientation. And this overhang has to be printed, or you're gonna have to use support materials. This piece that sticks out here, that's 2 millimeters thick, and this is only a single wall thickness. It's only 0.4. So it might be a bit wobbly. I'll have to ask Simon when he prints it what he thinks, if it's strong enough when you zip tie the 2 servos on there. The servos plus it should combine to be a bit more structural, but we'll see. Like, I don't want to fill up any more gussets or anything on the inside of this in case somebody has a longer battery or they need the space for something else. So we'll see how it goes. I'll see what Simon thinks. Maybe he doesn't like it. Maybe you guys don't like it. Let me know. This is the best option I've got for mounting the servos so far. And yeah, with a few changes, I'm sure this method will work really well. But yeah, we're getting there. So there you go. That pretty much covers it. I'm really happy with the way those turned out. Like I said, I might make some changes to that servo mount, but we'll see. I don't know. We got to print it. We got to test it out. And if it needs more structure, then figure something out. I don't know. We'll work it out. So yeah, that pretty much covers it. Please jump in the comments. Let me know what you think. Hit like, hit subscribe if you haven't. I'd really like to see this channel grow a bit more, especially with how close it's getting now that I'm going to start printing stuff and trying stuff out. I am so excited to see this happen. I'm like I said, I'm counting down the days for my printer to arrive here. I cannot wait to print this thing. So yeah, and also just a quick mention. You remember Lasse? He has been going above and beyond for me. He's been chatting with me on Discord. We're working out where the center of gravity and stuff, center of lift and pressure and wing loading and stuff like that with the tools that he mentioned. He's having a bit of a headache getting this front canard set up to work in that software properly, but it's looking promising. I've sent him some more details so we can get more accurate simulations done, and I'm just waiting to hear back from that. But yeah, I'm super excited to find out if this design is not going to be a waste of time, because it could well turn out to be a waste of time, and I really don't want to see that happen. So yeah, I've been Chaos, and as always, expect the unexpected, and I will see you guys next time. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.